Alright, we're going to look at this video linear speed versus angular speed. So what we're looking at here is a radius of 10 meters, and in 40 seconds the central angle of a sixth of a radian is swept out. What's the linear and angular speeds? So what we're going to do to find the linear speed, that's the arc length, how the arc length is changing as time goes on. So if you take a radius of 10 meters, right, that's the radius, the arc length is that times the central angle in radians. So 10 over 6, that's 10/6. That is our distance. All right, I'm going to change that to a fraction, which will reduce it to 5/3. And so 5/3 meters in 40 seconds. So I'm going to take that 5/3, I'm going to put it in a parentheses, so 5/3 meters in 40 seconds. All right, and it says an integer or a simplified fraction. I need to switch this back to a fraction. That's a decimal. So I need to switch it, math 1, back into a fraction. That's 1/24th of a radian per second. All right, so I'm going to put 1/24th there, and then the units are 10 meters. That'll be meters per second. Okay, linear speed is your radius units per your time units. So meters per second. All right, then the angular speed is how the angle is changing. So that is the radian measure right here, 1/6 in 40 seconds. So I'm just going to do again the fraction 1/6, divide that by 40, and then it once again simplified fraction, so math into a fraction. So that's 1/240th, so 1 over 240, and then these units are radians per second. So the angular speed is measured in radians per second. The linear speed is arc length per second, which is again the same units as your radius per second.